All right, in this video, we want to solve these, integrate these functions over here using integration by substitution. Now, these are not the simplest questions, but they're also not the hardest questions. So definitely these are types of questions you want to know going into your test or your exam, because very likely this kind of difficulty will show up. You will be required to solve it. Let's take a look at the first one over here. I have x and x over there. If I drive x, I get a constant, but generally speaking, when you have the same thing, you want to always pick whatever u is inside a square root or inside a bracket with an exponent. So I'm going to pick u as x plus 1. Let's derive it. And cross multiply to isolate the dx. So du just equals to dx. Then I can do my substitution over here. Can't really substitute x with anything just yet. This is just a u, and then dx is just du, so I can't get rid of the x over here. I want to just isolate my x over here, so u minus 1 equals x, and then I can substitute that over there. I'll rewrite this as u to the half to just make things a bit easier. Before I can integrate this, I just want to simplify it a bit. I want to start by just splitting the denominator. And then just simplifying. So if I subtract exponents there, I just have u to the half. Here, if I move this to the top, I just have u to the negative half. Now we can integrate, which is pretty simple. It's just u to the 3 over 2 divided by 3 over 2 minus u to the 1 over 2 over 1 over 2 plus c. Then I can just simplify these fractions. And then last step is to just substitute my u back into this question. My u is just x plus 1. Oops, not u, x plus 1. And that would be my final solution to this question over here. Go to the second question of this video. So for this one here, again, we have two terms. If I drive this, I'm not going to get that. But again, because this has an exponent here, I want to select u as t squared plus 4. Otherwise, it's going to be basically nearly impossible to simplify. So next, I'm just going to derive this over here. Cross multiply, isolate dt. Then I'll do my substitution to begin with. So 3t cubed cannot really be replaced. This can be replaced with u, and dt can be replaced with du over 2t. Now these two t's can cancel, and you're just left with 3t squared over there. Well, I still have a t squared to get rid of, so I can isolate t squared in this equation. T squared is just u minus 4. And then I can substitute u minus 4 back for the t squared over there. So I have integral 3u minus 4 times u to the 5 du over 2. Now I can just simplify this and then integrate it. I'll start by just bringing this 3 over 2 outside the integral because it's a constant. And then over here, I'll multiply the u5 by this bracket. So it becomes u6 minus 4u5 du. Now I can integrate this. So that's just going to be u to the 7 over 7, and this is going to be 4u6 over 6, and then I just have my plus c at the end. I can multiply this 3 over 2 with this fraction here, so that's just 3u7 over 14. 3 over 2 times negative 4 over 6. That's basically negative 2 over 3, so that and that will cancel, so it's just minus u to the 6 plus c, and last step, I just replace the u's back with t squared plus 4. That is my final solution for this second question over here. Pretty common type of question on a test, so definitely should know how to do that one. Third question here is a trig question. We have tan 2x plus cot 2x squared. No real substitution I can do just yet, so I want to start by simplifying this equation. I'm just going to square the bracket to begin with. That's going to give me tan times tan is tan squared 2x. Tan times cot is tan cot, and then cot times tan is cot tan. So it's going to give me 2 tan 2x cot 2x. I'm just going to show that in one step, not two steps. I don't want to take too much time to write it out. And then cot times cot is cot square 2x dx. So now that I've expanded all of this out, I want to simplify it because, first of all, can't really integrate tan square because the derivative of nothing really gives me tan square. I can't really integrate that. Need to figure out how to simplify the same problem for cot as well. There's no derivative of any function that gives me cot square. So instead, what I want to do is I want to simplify. I know that tan times cot, if you have the same thing in the bracket, tan times cot is 1 because cot is just 1 over tan, and then the tans will cancel. I know these two cancel to just give me just 1. And then I need to get rid of tan square and I need to get rid of cot square. So I'm going to use my trig identities over here. You know that tan square is just sec square 2x minus 1. In the middle here, I just have 2 times 1, which is 2. I know that cot square is cosecant square 2x minus 1. Now I can simplify this by combining like terms. Negative 1 plus 2 plus 1 just cancels out. That's just 0. So I'm just left with integral of sec square 2x plus cosecant square 2x. And now I know that from my derivatives, if you remember your derivatives really well, or if you go and look up the derivatives of the trig functions, you know that both of these over here, sec square and cosec square, have derivatives. So if you derive some trig equations, you get these, which means that we can integrate these over here. It is possible to integrate these. So we're going to integrate these, but before we can integrate them, we have to first do our substitution, and we are going to select u as 2x over here, because if I drive that, I'll get a constant, just basically outside. So we'll do u equals 2x, du over dx equals 2, du over 2 equals dx. And now let's do our substitutions. I have sec square u, which is going to be very easy to derive, plus cosec square u, which is also going to be easy to derive, and then du over 2. You can pull out this 1 over 2 to the front if you want, and then I'm going to integrate this now. So the integral of sec square is just tan x. So that's just tan u. And the integral of cosec square is negative cot x. So this is just going to be negative cot u. And then I just have a plus c. Then we can just distribute this 1 over 2 into the bracket. So tan u over 2 minus cot u over 2 plus c. And then last step, just replacing u with 2x. So my final answer is tan 2x over 2 minus cot 2x over 2 plus c. If you made it to the end of this video and you found this content helpful, please hit that like and subscribe button. Thank you for watching and have a wonderful day.